In this video we are going to learn about the VLE on the Aspen Plus. So we are going to generate PXY and TXY graph on the Aspen Plus, and then we will apply these graphs on flash drum and distillation column, because VLE is mainly used for distillation column. So I am assuming that you know the VLE, but for short explanation, so VLE will tell the amount of species in vapor and liquid phase at a given parameters. Okay, parameters like temperature and pressure. So it also tell you the region where both vapor and liquid exist. Okay, so now I will show you how to draw these PXY and TXY graph on the Aspen Plus. So for that we have to take a system of chemical species. So our chemical species will be water and 2-propanol. 2-propanol. Okay, rename. Now we have to give the method. So I am taking ideal method for this case. Then click next. So everything is fine. Now we have to generate the PX and TXY graph. For that we have to go to the analysis and then binary. Okay, so in this window we can see that our analysis type is TXY graph. Okay, and your basis is mole fraction. Now we are calculating the keeping your pressure fixed and varying the temperature. So I am converting it to 1 atmosphere. So now we can run the analysis. Okay, so this is how you can generate the TXY graph in the Aspen Plus. So this graph will show you the regions where liquid and vapor exist and liquid plus vapor both exist. So between these two lines vapor and liquid will exist simultaneously. So above this line only vapor exists, and below this line your liquid exists. So this green line is known as dew point line. So when you decrease the temperature from 100, okay, then it will come down, and at this green line the first drop of liquid will appear. So from 100, so above this green line there is vapor only. So when you decrease the temperature, when it reaches to this green line, your first drop of liquid will appear. Okay, now in the same way, when you increase the temperature and increase up to this blue line, so your first vapor bubble will appear. So this is known as bubble line. Okay, bubble point and dew point. Now how can we apply this in your flash drum? So let's see. So for that let's create a field stream. Okay, now we have to give the input. So assuming 25 degrees Celsius and 1 bar pressure, so our pressure is 1 bar and 1 kilomole is your flow rate, kilomole per hour. So 0.5 and 0.5, it means 50% is water and 50% is 2 propanol. Okay, so now this is working at 25 degrees Celsius and 1 bar pressure. Your flash is working at these conditions. So it will create some results. So let's analyze the results. As you can see, so everything is in liquid form. So your flash is at 25 degrees Celsius. Now let's go to the TXY diagram. So you can see your vapor liquid equilibrium exists above 82 degrees Celsius. Okay, now and when your water is 50%, so this is the line we have to follow. Okay, so now according to this mole fraction, so when the mole fraction of water is 50%, so at this point your first bubble will occur. Okay, now you can see if I increase the temperature to 70 degree, let's see, still liquid is there. As you can see, we are still below this point. So this point is 89.3. okay, so at 89.3 your first vapor or bubble will produce. So now just write 89. Let's see if it's work. Okay, so why it is not okay? So this is because okay, your pressure is 1 atmosphere. Now I have to change the pressure to 1 atmosphere. Okay, now everything should be in liquid form according to our see. So according to our graph, TXY graph, everything should be in liquid form. But when we put 89.3, now vapor and liquid should exist. See, okay, at 1 atmosphere. So there should be some more value after the point. Let's see. Okay, at 50, what is the point? 89.3. okay, this is because there should be some values after the point. So let's take 89.5. okay, now it will show liquid and vapor both. See, now it is showing you liquid and vapor. Now your vapor is very less, as you can see, and almost all is in the liquid form. Now I increase the temperature. So if I increase the temperature to to 90, see, your vapor fraction will increase. As you can see, from your liquid fraction before was 0.93, now it is 0.7c. So your vapor fraction is increasing and your liquid fraction is decreasing. Let's go to a point. If you have water 50% and if you touch this point, so this point is 92.2 and your 50, so it should be like 92.3 or 5 or 3 or 4. All of your liquid fraction will be converted to vapor fraction. So 92.3. So everything should be in vapor fraction. See, now everything is converted to the vapor fraction, nothing in liquid fraction. So this is how you can do your separation from flash using the TXY diagram. Now take one more example, like if you change the pressure, now pressure is 5 atmosphere, let's assume. So this is your TXY diagram. At 5 atmosphere, so water and 2 propanol will have this VLE. Now apply this VLE for your flash separation. Okay. So your flash is operating at suppose 120 degrees Celsius and at 5 atmosphere pressure. So now take some other fraction. If I change the fraction of water to 0.45, so it should be 0.55. okay, and so now which one? So we have to follow this line. Okay, 0.45 mole fraction of water. As you can see, if you increase the temperature, your bubble point, the first bubble will appear at somewhere between so what, 138 and okay, what is this? This is also 138. How it is possible? So this is 138. This is also 138. Okay, let's see. Okay, around 138 your first bubble should appear. So let's see. So at 137 everything should be in liquid form. See, everything is in liquid form. Now if we change it to 138, okay, now your vapor should appear. So okay, that is because of those points, so we have to take some 139, correct, then take 139. See, your vapor is 0.299. okay, there is a lot of vapor. So if I change it to 138.5, okay, see, so around at 138.1 your vapor will start appearing. Okay, now if we see when, So between these two lines, everything, your both liquid and vapor should coexist. So above this line, your only vapor should exist. So if you follow this 0.45 mole fraction and at this, so 141, around 141, all of your liquid should convert into vapor around 141. So I will take 141.5. okay. So this is, so you still have some liquid. It's very less, but still there is some liquid. So I will take 141.8. So now, so everything is in vapor phase, as you can see. Okay, so this is how you can use your TXY diagram to separate the chemical species in the flash drum. Okay, now suppose you have PXY diagram. So how can we apply this PXY diagram? Okay, so change this TXY to PXY diagram. So this is your 25. Now PXY diagram means you are varying pressure at constant temperature. In TXY diagram you are varying temperature at constant pressure. So your temperature in this case is 25°C. So first reset and then run. Now you should run the analysis. Okay, so this is your PXY diagram. Okay, so now if you see, below the green line everything should be in vapor phase, above this blue line everything should be in liquid phase, correct? And then between these two lines your vapor and liquid should coexist. Okay, now let's check this and separate these two components. So your temperature is 25 degree, it's constant. Okay, now what, as we can see, so your mole fraction of water is 0.45. okay, so you have to change this pressure up to this point. So this point is 0.0423. okay, 0.0423 bar, I think it's bar, let me check, cross check. 0.0, okay, yes, this is 0.0423 bar. Okay, so I'll change this to bar. 0.04, okay, just keep it this. So 0.04 is below 0.0423. So below that everything should be in vapor phase. Okay, now if I change this to 0.0423, everything should be so there should be some vapor, liquid, because below that there is only vapor. Okay, so first liquid drop should appear, as you can see. First drop of liquid appears. Now if I increase 0.0425, your liquid fraction will increase, as you can see. Okay, now if we go above this point, then only liquid should exist. So this is 0.046 bar. So above 0.046 everything should be 0.046. Everything should be in liquid form. Okay, so there is a vapor also, because that point is not exactly on the mole fraction, 0.45 mole fraction. So if we increase 0.047, let's see, okay, everything is in liquid. Okay, now you see everything is in liquid. So this is how you separate the chemical species using flash with the help of PXY and TXY diagram. Okay, you can also try this with ethanol water binary mixture. So if you try that, then you will gain confidence and you can easily learn how to see the results. Okay, so if you connect, so how this VLE helps is you have to you will separate this mixture based on the parameters. So if you keep like um, many flash drums on top of each other, then it will be behaving like a distillation column. So each flash drum will be a stage in the distillation column. Okay, so this is how you can use this VLE in the distillation column also. We will do this in on the distillation column in the next lecture. Okay, hope you like my video. Kindly comment, subscribe and like my video if you find it informative. And if you want to know more about Aspen Plus, then you can contact me on my Gmail. I will provide it on the in the comment box. Okay, thank you very much. Take care.